Good evening, students. Today we will see a different portion, that is dual nature of radiation, in the topic photoelectric effect in grade 12. Already I have posted one video in laws of motion regarding all the concepts, how to identify, how to solve the problems, etc. Here also we will follow the same. For that, before going to this photoelectric effect, we will see some of the basics. So the first one is the energy of an electron in the nth orbit is given by En is equal to minus 13.6 n square electron volt. The meaning is that here this n is the principal quantum number. Suppose this is the proton, this will be n is equal to 1 first level, it will be second level, it will be third level. Suppose an electron is in the first level, it will have an energy, total energy of minus 13.6 electron volt. Just substitute here 1. Suppose the electron is in the third level, it will have a energy of minus 1.51 electron volt. Suppose if we want to remove an electron from the outermost level, that is the third level. In third level the energy is minus 1.5 electron volt. So to remove an electron from the third level or third orbit, we have to supply an equivalent amount of this energy in magnitude value equal to 1.51 electron volt. So I will write an equation here. So energy of the electron plus energy supplied is equal to 0. The meaning is that the kinetic energy and the potential energy is 0. I will explain this. So what is the energy to be supplied? Suppose delta E is the energy supplied to be supplied, that delta E will be equal to minus of total energy. The total energy is minus 1.51 electron volt. So we have to supply an energy equal to minus of total energy, that is equal to minus of minus 1.51 electron volt, that is 1.51 electron volt plus 1.51 electron volt. If we supply this amount of energy, we can remove an electron from the third orbit. Suppose I am considering a hydrogen atom. For hydrogen atom, there will be one proton and one electron only. Level n is equal to 1. So this electron will have an energy equal to minus 13.6 electron volt. Suppose if we supply plus 13.6 electron volt, we can remove the electron from this hydrogen atom. Suppose if you are supplying an energy equal to 15 electron volt. So what will happen? This 13.6 electron volt will be utilized to remove the electron from the atom, and the remaining energy will be utilized as the maximum kinetic energy of this electron. Maximum kinetic energy of this electron. So suppose if you are supplying 15 electron volt, so 13.6 to remove the electron, remaining will be the maximum kinetic energy of the electron. So already I have told that if 13.6 electron volt alone is given, there will be no kinetic energy. It will just remove the electron alone. If excess of electron energy is given 15 electron volt, remaining 1.4 electron volt will be the kinetic energy of the electron. Okay, I hope you might have understood. So this energy level diagram will be useful in case of unit atoms and the nuclei. So see here, this is the first energy level, second energy level, third, fourth, fifth. But this n is equal to 2 is the first excited energy level. N is equal to 2 will be the first excited energy level. N is equal to 3 will be the second excited energy level. It goes on. So while solving the problems, they will say the electron is in the first energy level or first excited energy level. First energy level means n is equal to 1. You have to take this energy. If it is first excited energy level, then you have to take this minus 3.4 electron volt for calculation. Consider one example. Suppose this is Earth. From the Earth or distance, a satellite is revolving around the Earth. If this satellite will have a total energy equal to, we know that total energy of the satellite is equal to minus of g mass of the satellite, mass of the Earth, mass of the satellite divided by 2r. This will be the energy possessed by this satellite. If we give an energy equivalent to in magnitude this value, this satellite will escape from the Earth's atmosphere. Clear? So likewise for an atom, this is the proton and suppose this is electron. I am considering hydrogen atom 1H1. This in the outermost level, first level, it will have an energy equal to 13.6 electron volt minus 13.6 electron volt. If we supply plus 13.6 electron volt, we can remove the electron. If we supply more than 13.6 electron volt, that is 15 electron volt, we can remove the electron, as well as the electron will gain a maximum kinetic energy. So this energy is called threshold energy, and the frequency in that energy relation is called threshold frequency. So today we will see different types of emission. This is photoelectric emission. What is that? Consider a metal, any metal. It will have a large number of atoms. If light energy is supplied, h mu, the energy is supplied h mu, E equal to h mu. This electrons from the outermost electrons in the atom can be removed. That electrons are called photoelectrons, and that effect is called the photoelectric effect or photoelectric emission. Second, suppose if you are considering an atom, we have to supply heat. This electron will possess some energy. If we are supplying heat continuously to that atom, the heat energy supplied is equal to that energy possessed by that electron, then the electron can be removed. It is called thermal emission. Third one, suppose in an atom, if we are supplying continuously an electric field, this atom, the outermost electron will have some energy. We are continuously supplying electric field. The electric field energy is equal to that energy possessed by that electron. So this electron can be removed. This emission is called field emission. And suppose in any case, in these three cases, the electron emitted is once again bombarded by another atom. Suppose here we are having two atoms. An electron is removed from this atom. This electron is bombarding this atom and removing another one electron. That type of emission is called secondary emission. These are some of the types of emission. Okay, photoelectric emission. Consider a plate. It is having a large number of atoms. The outermost electron in that atom, suppose it is 2 electron volt. So to remove that 2 electron volt, we have to supply a photon of energy of the photon greater than 2 electron volt. Then only we can remove the outermost electron from that atom. So if we are supplying more energy than this 2 electron volt, this electron will attain a kinetic energy, maximum kinetic energy. That maximum kinetic energy is given by the formula kinetic energy max is equal to h mu minus phi. This phi is the work function of this metal, that 2 electron volt. H mu is the energy supplied by the photon, light photon. So this can also be written as H mu, you know that hc by lambda by pi. Kinetic energy maximum is equal to 2 formulas. One h mu minus pi, another one hc lambda by pi. This pi is called work function. Mu is the frequency. Ke max is the maximum kinetic energy of the electron. Okay, we will see one problem related to this relation. Consider a metal. It is having the outermost electron is having an energy equal to 2 electron volt. If a light of wavelength 400 nanometer is supplied to this metal, what will be the maximum kinetic energy? So kinetic energy is equal to kinetic energy maximum will be equal to h mu, that is equal to hc by lambda minus pi. This pi is work function is 2 electron volt. So this hc can be hc by lambda can be represented by in electron volt by a formula 1242 divided by lambda in nanometer. So the final answer will be in electron volt. Otherwise, if you want to be in electron volt and wavelength is in Armstrong, so it is 12400 divided by wavelength in Armstrong will give you the answer in electron volt. That is the energy value in electron volt. These two steps you have to keep in mind. 1242 divided by wavelength in nanometer will directly give the kinetic energy value in electron volt, and 12400 divided by wavelength in Armstrong unit directly give the energy value in electron volt. So what happens here when we supply these values? So here if you are supplying this 1242 divided by 400 minus 2 electron volt, this value will come to 2.98 electron volt. Minus this 2 electron volt, you will get 0.9 electron volt. This 0.9 electron volt is the maximum kinetic energy attained by the electron. So next we will see about what is stopping potential. Before that, I will explain how this stopping potential is calculated. Suppose if you are considering two plates and it is connected to a battery. Here suppose the battery is 5 volt. Here the positive of its 5 volt, here it is 0 volt. Suppose a light is emitted here with a particular wavelength. There will be a it will try to remove the electron, and the electron will have some maximum kinetic energy. For example, the electron kinetic energy is 2 2 electron volt, for example. So what happens here? We have to calculate how much kinetic energy is provided by that battery, so that this electron will move from here to here, that is positive potential to negative potential. For that we will use the conservation of mechanical energy. Before that, for the potential energy of electron of a system can be given by the formula Q into V, V into Q. Suppose here we are considering, here it is, what is that? Initially kinetic energy is 0, it's not connected to the battery. So if you are applying the mechanical energy conservation, then kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Here kinetic energy initially it is 0, but potential energy it is Q into V. Suppose the charge is Q and the voltage is 5, that is equal to 5Q. That is kinetic energy final, we don't know. Potential energy here it is how much? 0 into Q into 0. Charge is Q, voltage is 0. So the kinetic energy final will be equal to, kinetic energy final will be equal to 5Q. That is nothing but potential energy initial potential energy. So this charge will move here and it will attain a kinetic energy is equal to 5Q. So our question is that from 0 to 5 volt, here the kinetic energy required is equal to 5 electron volt. What will be the minimum kinetic energy required by this charge to move to the other plate? For that, how much potential is supplied? That potential is called stopping potential. So we will see some examples and we will understand clearly that what is stopping potential. See here, this is a positive negative plate and light is incident on this plate. Electron is removed. The electron is, suppose it is having a maximum kinetic energy. Kinetic energy is equal to 2 electron volt. Here the energy supplied here is what? 5 electron volt. So this will be the stopping potential and this electron will not move from here to other end. So this potential is called stopping potential. This stopping potential, we will reverse the battery and we will give, that is minus 5 volt. Here it attained only 2 electron volt, so it won't move from this plate to this plate. Some more explanations to understand what is stopping potential. The negative potential has to be given. Suppose a light is dropped on this metal. The electron is emitted and it is having a maximum kinetic energy of 5 electron volt. The electron is having a maximum kinetic energy of 5 electron volt. In this battery we are supplying 0 volt. What will happen? This 5 electron volt can move here, this 3 electron volt will move here, this 2 electron volt will move here, this 0 electron volt will not move to the other end. Suppose here we are supplying the battery to 10 volt. We are changing the battery voltage to, here the stopping potential is 0 electron volt. We are changing the maximum kinetic energy applied, got by that electron, photoelectron is 5 electron volt. If we are supplying 10 electron volt, what will happen? This 5 electron volt will also move, 2 electron volt will also move, and 0 electron volt all will move to the other end. Suppose here we have changed the polarity. Suppose it's attaining an electron volt of 2 electron volt. That is the threshold frequency energy or the maximum kinetic energy of the electron attained when a light is embedded here. So if we supply 2 electron volt, what will happen? This 5 electron can move here, 3 all will move here. These 2 cannot move. Suppose the energy, maximum kinetic energy is 5 electron volt, and if you are supplying 5 volt, what will happen? This 5 electron volt cannot also move to the other end. All will not move. So this will be the stopping potential in the first case, and this will be the stopping potential in the second case. See here, if 2 volt is applied and the kinetic energy maximum attained by an electron is 2 electron volt, all the remaining 3 can move to the other end. Less than that values cannot move here. But if 5 electron volt is the energy, and if you are supplying 5, no electron will move from this plate to this plate. So saturation current. What is saturation current? Suppose the light photon is emitted on the plate, all the electrons are embedded and it is waiting for to move from here to here. Suppose I am supplying a volt equal to 100 volt. All the electrons will move here. Suppose I am increasing the voltage to 1000 volt. Then also all the electrons here will move to the other end. The meaning is that the electrons are limited. The electrons are limited. When potential is increased, the current will be constant only. If 5 electrons have gone to the other end, then the current is 5. If 100 volt applied also, or 1000 volt applied also. So the meaning is that the electrons are limited, so that when voltage is increased, current is constant. That current is called saturation current. If 100 volt is applied, the 5 electrons will come here. 1000 volt is applied, the 5 electrons will come here. So electrons are limited. When voltage is increased, current is constant. That current is called saturation current. Okay, so we will see some of the graphs. So first, stopping potential versus frequency. Before that, we will do one problem. So lambda, wavelength of the light incident, is equal to 400 nanometer. Work function of the electron is 2 electron volt. We can find the kinetic energy maximum. So the kinetic energy maximum will be equal to how much? Hc by lambda minus pi. So 1242, standard value 400, it's minus 2. So it is 3.1 electron volt minus 2, that is 1.1 electron volt. So this is the maximum kinetic energy attained by the electron. So kinetic energy max is nothing but changing potential energy. Already we have discussed that. So potential energy is nothing but voltage into charge. So it is voltage into charge. Suppose if you want to find the voltage, divide the charge with the kinetic max. So kinetic max is divided by charge, you will get one potential. That potential is called stopping potential Vs. Suppose, so here if you are dividing by the electron charge, you will get 1.1 volt. That is the stopping potential. So that will be the stopping potential. I hope you can understand this. Kinetic energy maximum is 1.1 electron volt. We know that kinetic energy max is equal to change in potential energy. Potential energy is voltage into charge. If you want to find that voltage, divide totally by what charge, you will get the stopping potential. Suppose if you want to find the stopping potential here, it is 1.1 electron volt divided by charge of electron, you will get 1.1 volt. This will be stopping potential. This is maximum kinetic energy. So we can derive the relation in this graph. Let us draw the graph. So we know that kinetic energy maximum is equal to h mu minus pi. This pi is our function. Okay, so suppose if you are dividing all the term by what? Charge of the electron. This term will become the stopping potential. That is equal to h mu by E minus pi by E. Say here h mu by E. This h is also a constant, E is also a constant. So this can be written as Vs is equal to h by E into mu minus pi by E. This is a resemblance to an equation y equal to mx plus c. Here it is in the form of mx minus c. Here m is equal to what? H by E. Slope. Slope is a constant, it is not going to change. Why it's not going to change? This is also a constant, this is also a constant. The slope will be same. What is y-intercept? Here the y-intercept is pi by E. It's minus pi by E. So the how to draw the graph? So when you draw a graph like this will be the slope theta, and this point is called what? Pi by E, y-intercept. Pi by E. Suppose if I want to calculate this point, what is this point? So put stopping potential equal to 0. So stopping potential Vs is equal to h by E into mu minus pi by E. Substituting here it is 0, that is h by E mu minus